Hello, in this video I'm going to talk about coordinate geometry in 2 dimensions, specifically about distance and midpoint. The formulas for distance and midpoint in 2 dimensions are given on page 2 in your formula booklet. There's the distance formula, there's the midpoint formula. The distance between 2 points is the length of the line segment that joins those 2 points. In the example shown, Pythagoras' theorem can be used to calculate the distance between the 2 points given. If we first subtract the x-coordinates of the 2 points, as shown, given a equals 4, then subtracting the y-coordinates of the 2 points to give b equals 3. Substituting these values into Pythagoras' theorem will give us the length of the hypotenuse, c, which is equal to 5. So the distance between the 2 points is 5 units. So in general, Pythagoras' theorem can be used to calculate the distance between the 2 points x1, y1 and x2, y2. Subtracting the x-coordinates to give a, subtracting the y-coordinates to give b, and replacing the hypotenuse c with the letter d for distance. Substituting these into Pythagoras' theorem gives us the distance formula. And as already mentioned, this formula is given on page 2 of your formula booklet. In this question, we have to find the distance between the 2 points given. So if we start by stating the formula. And then identifying the points. If it helps, you can draw a diagram, as shown. And if we substitute the values into the formula, simplifying the calculation, type in the calculation into the calculator, so shift to get to the square root, and then we'll open a bracket, 3, take away, put -1 inside a bracket, close that bracket, square that, and plus do the same thing, open a second bracket, 2 take away 4, and close that bracket, and square that. And pressing the decimal display gives a distance of 4.47, correct to 3 significant figures. The midpoint of 2 points is the point midway or halfway between the points. In other words, the point halfway along the line segment. In the example shown, the coordinates of the midpoint, m, are found by taking the average of the x-coordinates and the average of the y-coordinates. If we first start by identifying the x-coordinates, that's 3 and 7, and finding their average by adding them up and dividing by 2, giving a value of 5. Repeating the process for the y-coordinates, identifying them as 2 and 5, and finding their average, in this case 3.5. So the midpoint m of the points given is the point 5, 3.5. Repeating the process for the 2 points x1, y1 and x2, y2, identifying the x-coordinates, x1 and x2, and working out their average by adding them up and dividing by 2. Doing the same for the y-coordinates, y1 and y2, finding their average by adding them and dividing by 2. So the midpoint M has coordinates x1 plus x2 divided by 2, y1 plus y2 divided by 2. Again, this formula is given in page 2 of your formula booklet. In this question, we're asked to find the coordinates of the midpoints of the line segment AB. So if we begin by stating the formula, and then identifying x1, y1 and x2, y2 as shown. Then if we find the average of the x-coordinates by adding -1 and 5 and dividing by 2, giving a value of 2. Doing the same for the y-coordinates, giving a result of a half, or 0.5. Therefore, the midpoint M of AB has coordinates 2, a half. In this question, we're told that M is the midpoint of AB, and we're told that the coordinates of M are 4, 3, and we have to work backwards and work out the coordinates of point B. So we can start by drawing a diagram and marking on the points A and M as shown. To identify point B, if we first subtract the x-coordinates between A and M, giving the value of 5, so in moving from A to M, we must move 5 units parallel to the x-axis, as shown. Then subtracting the y-coordinates of A and M, given a value of 4, this represents the 4 units that we must move up, or parallel to the y-axis, to get from point A to M. So now if we repeat that movement, but this time starting from M, moving 5 more units parallel to the x-axis, and 4 more units parallel to the y-axis, as shown. And our endpoint will be B, which is at 9 across and 7 up. So therefore, B has coordinates 9, 7. Alternatively, we can approach the problem algebraically. And to do this, we should start by stating the formula, writing down the coordinates of A and M, substituting in the values for the x-coordinates to give an equation in x2, and similarly for the y-coordinates to give an equation in y2. So we can solve these equations algebraically, giving x2 equals 9 and y2 equals 7, as before. Or we can solve the equations on your calculator. And to do this, from the main menu, select Equation, and select F3 to solver, and F2 to delete any previous equation, and F1 to confirm the deletion. And then type in the equation for x2. Start by pressing a fraction button, and numerator, so that'll be -1, plus use the x variable, and the down cursor to get to the bottom, and 2, and then the right cursor to come back up, and then shift to get to equals, and then 4. Pressing execute to enter the equation, and noting that the answer next to x is not the answer to this equation, as we haven't pressed solve yet. Pressing F6 to solve the equation gives x equals 9. Then typing in the equation for y2, and to do this I press F1 for a repeat calculation, and then F2 to delete the previous one, F1 to confirm that. I can now type in the second equation. So again, pressing the fraction button, -1 plus, we use the same variable for the x for y2, down cursor, and then the 2, and the right cursor, and again shift to access equals, and 3. Pressing execute to enter the equation, and F6 to solve the equation. With the value of 7. So again, the coordinates of point B are 9, 7.